Welcome back everyone. Today we're going to do a video on getting the most out of your UltraStryfe / Swordfish and the different variants. This has been particularly interesting for me and hopefully you guys out there. We have a Facebook group and sometimes people post rather disappointing results FPS wise with their UltraStryfes and whatnot, and it's try as much as you can remotely, you know, from the other side of the world. You can't necessarily resolve their issues. So this guy sent in his blaster to me to have a look, which I really wanted as an example of one that was getting really poor results. Now I chronoed this. It was getting all over the place from like 140 to 160 FPS, but that does depend on the darts, of course, but very inconsistent and pretty low for the effort. I've got it a lot better than that. I was hoping that there was going to be some single smoking gun, if you like, that was going to be the answer to why it was not wonderful, but that wasn't the case. It was many issues that just all added, you know, a few more FPS to it. So everything I'm going to talk about today were issues on this blaster, and they may be an issue on your blaster if you're not getting enough FPS or if you want more FPS. So I guess before we really start on the blaster itself, we need to talk about darts. Okay, so we need to remember that darts are a huge impact on the FPS you're going to get. So this is a short dart. You'll always get less FPS shooting this than this because the wheels are applying force to the whole length of the dart. So if you make the dart shorter, you'll get less FPS. You can get fake ones. These are like fake darts from AliExpress. These were horrible, and I can only get about 150 FPS even after re-gluing these on. I do have other ones which are these two here. These are E-kind. I got them from AliExpress, that's fine. And these are much better AccuStrike ones than the real cheap nasty ones. So I always get them actually in the box, and the reason why I get them in the box is because I've bought too many darts outside of the boxes and they get sent in the mail and they get completely trashed in the mail and they're all completely destroyed. They've got these two over here, which is the men gun, I think. I don't particularly like these because the end is too hard for shooting people with it. And these ultimately were not the best for FPS wise because I think it's the way that the end is. I mean, obviously, when you're pulling force like this, which is what happens when it goes through the dart, through the blaster, it's pulling it like that. And there is a difference depending on whether or not it lines up with this ridge there, which is obviously a much better pulling than over here. And that also can be a bit weird on these ones here, where it actually depends on which way it goes through the dart, through the blaster, relative to the wheel direction. Whereas these are far more symmetrical, though not ideal because there is still it's softer here than there. You do have Kush Gen darts. Now if you want to get the highest FPS possible, you can cheat and shoot Kush Gen 3s. These get way more FPS than anything else, but they are horrific. You do not want to use them. You cannot hit anything at all unless your person is this close to the barrel. You won't hit them. They're like useless. They're like what are they called? Elite darts, possibly even worse than elite darts. I never use elite darts because, you know, there again, they cost $2 trillion and are useless. So I always like AccuFake, and I have a belief, but not proven, that actually the color even makes a difference depending on how much FPS you get. Because I reckon the blue ones have got harder foam than the yellow ones, both made from E-kind. And obviously, obviously, brand new darts you have to use. You don't have to use brand new darts, but if you're worried about FPS, a brand new dart will always get more FPS than a well-worn dart, because as it goes through, you're effectively sanding some of this off, and people stand on them, they get bent. So if you're FPS chronoing wise, you always have to use brand spanking new darts, which means that testing gets expensive. I've put about 100 darts through this blaster to find out what was wrong with it and improve it. Okay, so moving on to we're going to work away from the front to the back. We're currently missing the front. So you will be aware that this should be on the front of this, on the front of the blaster. Now this customer actually had one of these, which is an aftermarket part, and this was a big contributing factor to the performance problems. If we just pop this on here, the stock one, yes, this is not on there. You can see that the mounting holes are directly in the center, and if you look down the barrel, it is round. No surprises there. However, this one here, that is totally not the case. You'll see that the holes are way off. It's not in the center. It is hard to get this on screen, so you know it's not in the center. None of those are. Now if you look down the barrel, it is not round. You can actually see that there is a big lump down there, and there's also a ridge on the inside. So I actually, to be fair, I believe that this was intentionally bought as a second because it was cheaper, but sometimes buying things because they're cheaper is a bad idea. So I'll personally resolve that by hopefully just drilling those holes out more and filing that down, and also removing the internal ridge. But obviously anything that the dart can hit is going to slow it down. Now it has a greater impact than you're going, well, that's not that big a deal. But when you have the barrel in it, in the blaster, and this is because the holes are not in the right place, it's actually bending up, so it's bending the barrel up, so it's hitting the inside of the barrel, and if that happens, that slows it down. So that was a big contributing factor, but probably not normal. I mean, you probably just normally have that, and that won't be a bigger deal. So moving on to barrels. So there are 3 different kinds of barrels, if you want to call some of them barrels. You have, this is actually a new one I'm going to put up there, which is basically just a standard internal diameter, whereas you can see this one has additional, I don't know what you'd call those, ridges. And the point of this being a smaller diameter is that this will increase accuracy. However, if it's increasing accuracy, it's meaning that it's going to increase drag, and it will be less FPS than this one here, which is producing less drag. So if you are concerned about maximum FPS, you do not want to be running a barrel like this. So this is really intended for the people that are going to be maxed out at 150 anyway, so you can't use the extra FPS, so why not have the extra accuracy? You have these things down here which are anti-jammers. That just helps to ensure that the dart always makes it down and doesn't jam. There is a version which does not have this barrel at all. It just has these little anti-jammers, and you can use your own barrel. Now the Stryfe comes with a normal barrel section here, an orange section which goes in there. I don't happen to have it on hand right now, which you could use with just those anti-jammer parts. However, the stock barrels are bad news. They are rifled, and therefore if the dart touches them, it will slow it down. So never use the rifled barrel if you care about FPS. And sadly, just the shorter the barrel, the better you are. So if you have no barrel whatsoever, you're going to get more FPS than having this. And that's one of the reasons why the Swordfish is actually better, because this has an internal ridge in there, forcing it to have a minimum barrel length of about that long from there to there, which the Swordfish doesn't have an internal ridge, which means you can have a massive long barrel, or ideally you wouldn't, you'd just stop it. I have run it without just the anti-jammers and no barrel in these things. Now the next thing is that you get the performance out for the effort you put in. So this is obviously 3D printed, and I've kind of scored it down to try and make these ridges as noticeable. So you can tell that there's little ridges on there, right? Because it's 3D printed, and it's 3D printed vertically like this, up, and that means there are layer lines, and those little dots are starting and stopping ends. You should do it random. If you don't do it random start stops, you'll end up with a single line all the way down the inside, and that will be very difficult to get rid of. So no matter which one you use, you should sand it down. If you've ever stuck your finger down these, you're like, oh my gosh, that is super mega insanely rough. The idea is for the inside to be smooth as possible. So when the dart touches it, particularly on this one, which is really the idea is that the dart is gonna touch this, you want it to slow it down the least amount as possible, which means it needs to be super smooth. I didn't print this one, by the way. So how you do it is you need to sand the inside of it down. Now, this one's not super hard because it's got the larger internal diameter, but this one is like you can't get your finger down there. So how do you sand the inside down? You can't realistically use a file. So what I do is I take some sandpaper, and this is 800 grit, which is actually too fine really. Probably 600 would be better, and you just roll it up. Roll it up. The whole sheet, not a small part. And now that will fit down the barrel. Okay, so now you can, now no comments, you can go wild on it, right? You go spinning around and up and down, and you can remove all of the the layer lines and the little dots. So it's super smooth on the inside, which is what you want, including these, and that will help reduce the reduction in FPS if the dart does touch it. So you need to do that. Okay, we're now going to move on to the motors. Now, surprisingly, common problem is actually retaining the motor bolts. You need to make sure that the motor bolts are screwed on properly, which sounds pretty obvious. What happens is that it seems to be, after a bit of heating, maybe their PLA or whatever you printed out of it might do a bit of shrinking, and so these need to be retightened, and they need to be rather tight to begin with. And also, if you've pushed the bottom really hard into the base to 3D print it, you may find that these holes now have a lip on them, and when you're screwing it up, you're actually screwing it up onto the lip and not actually into the internal angle. So you need to get in there with a knife and just make sure that you've cut those around the whole size, so those actually fit in. And to be honest, it's surprisingly often that people have not screwed the motors actually into this plastic properly, and you can normally see that through one being slightly higher. That results in a bit of an angle. Okay, moving on to the cage. You need to make sure the cage is printed out of something that is rather rigid. Now this particular cage, I didn't print this, is printed out of some weird plastic. It is actually super mega bendy. It is like incredibly bendy. And it's also over extruded, and you can tell that because you can see, well, I doubt you can see it on the camera. In the middle, you've got these ridges on the top, which affects how low this motor sits, because that's happening inside there. But you need to make sure that this is printed as higher infill as possible, which this is not. I cut it. It's not super light, but it is not high rate. I like 85. You can do 100 would be better, obviously. However, if you slightly over extrude and you've printed at 100%, there's nowhere for the extra plastic to go, so this ends up being just like disaster. Well, it would look perfectly fine, but if you measured it would be quite far out. So if you do slightly over extrude, then 85 still gives you some space for the internal infill to sort of fill in that 85%. Okay, it's now about a month later since the original version of this video, which I didn't end up posting. I pulled it back down, made some changes, which is this change I'm going to comment about now. It's super important because it's made a huge difference to all Stryfe cages, which is a good thing. And I'm so glad that the user sent this to me to make these discoveries, which I think is not completely unknown, but anyway. So at this point in the original video, I have the original user's cage, and it's mounted in the Stryfe, and I talk about how in some cases the front is higher than the back, which I've obviously exaggerated right now. Now when this is down, you should be able to measure from here to here, well, here and here, and here and here, and it should pretty much be the same height. But you can even see right now that the front is actually higher than the back, and it's off by quite a long way, and that is super bad because it means you have to bend the barrel back, and it's obviously not coming straight down the barrel, and it might touch the sides of the barrel. I originally blamed this on the fact that people were unable to remove their supports from inside here, which was allowing the front to sit up a bit higher. However, under some investigation, couldn't even say however, I printed my own one and put it in there, and it is exactly the same. It is too far up at the front, which of course baffles me. I took this out and put it in my blue Stryfe, and it was perfectly level. I have investigated this, and the reason for this is that this post on this orange Stryfe is taller than the rest. Now the assumption that I've always made, and I think quite a lot of people, is that these were supposed to be a consistent height, these posts, and you mounted the cage down on top of those. However, like I've just said, I've just discovered that there is a variance in the height of the posts between the different versions of the Blaster, and therefore you cannot use the height of the posts for any kind of alignment. It does have these, I don't know what you call these sections here, down here, on there and around here, and that does appear to be a consistent height. I have measured other ones for interest's sake, like this one here is also not the same as my blue Stryfe, and weird stuff is different. Like the height of this here relative to this here is different on this orange Stryfe to my blue Stryfe. I obviously haven't gone through measuring everything, but it was just interesting to see that it must be actually a different mold for this to be different, or yeah, it can't be like a molding problem, which I could explain on these being different heights. So I have changed it. So this is the original one where we relied on the height of these posts for alignment. We've now gone away from that, and now we've gone to one like this, where I have filled in the bottom of it, and we're now relying on all corners to actually sit on these down here. Now that does mean when you screw this in, there's an intentional gap. It's so hard to see on the black one. It intentionally won't sit on top of the post, so there will be a gap, so don't over tighten it in an attempt to screw it down, and it's so much better now. So that was a huge benefit of getting sent an example of one that doesn't go very well. Now see, because that now sits down properly. Not that I've checked the back in this video. Yeah, so I've measured that, and that now sits down nicely, and it's shoots straight down the barrel. So there is updated versions of Gen 3, would you believe it, and Gen 4, and I'm actually going to updating the wheels as well, and for Gen 3 and 4 to improve cooling. I've made other changes to this. I have got rid of this. You can see I've put this line in here, and the original one was a curve. For some reason this Blaster also used to accidentally auto-load via suction or vibration, which is weird because it didn't vibrate very much. We'd get a random round sucked through it. So I've reduced the chance of that happening. It's generally stronger than in the past, and even this bit here, which you wouldn't believe, is now actually thicker than the original one, than this one here, but it actually is. And other little updates. Like making these holes. For some reason I hadn't countersunk these properly on the G4 that was on there. I don't know how I hadn't noticed that. So these have been much improved. So yeah, I mean this finding this and dealing with this has been one of the biggest benefits of someone sending me their Stryfe, and everyone download and print new ones. Yeah. Moving on to wheels. Now you'll see that these wheels have got some funny bits around them, and here's the other one. and that is because these wheels touch. Now if they touch, it makes a lot more noise, and they will self-wear themselves down, and the noise will pretty much subside. Now if your wheels do not fit on your motors, or they touch, this is not a design fault, this is a printing fault. The design is correct. You can measure the motors, and you can measure the gaps, and you can measure the wheels. They don't touch. If they're touching when you have printed this, either you've got too much shrinkage and pushed the wheels together, or your wheels are too fat. Now I know these are over, well I actually don't know if these are over extruded, because I haven't tried these in the cage I actually printed. I printed these wheels, but I didn't print this cage, and they touch. Now I have had a number of people saying, oh, the wheels don't fit, you need to change your design. No, the measurements are correct. You need to print them correctly. Print wise, print in full, the lower the better, really, within reason. I'm going to get someone print them at 1% now or something crazy. The lighter the wheel, the faster it will spin up, so that's good. I'm currently saying about 25% or even 20%, so like 85 for the cage and like 25 for the wheels. Yeah, and obviously the higher the crushed wheels, which in my system means lower the number, the greater the grip on the dart, and therefore the greater the FPS. So this was printed not by the user that sent me the blaster, but someone else printed them. He asked for the highest crush possible, which of course is not what he received, so he was not able to achieve fantastic FPS because he didn't have the greatest crush wheels. Okay, moving on to the other side of the blaster, which is the electronics. So this particular one has the, I think it's a Myco board made out of Australia. It has made life much easier, and it is smaller to fit in there. So I could definitely recommend that, but there are some things to be aware. When you flash your ESCs, yes, you need to flash your ESCs. You need to make sure that you set the enable throttle calibration, a little tick box. Otherwise, it'll randomly reset the following settings that I'm going to talk about now. Now, this sends information to the ESCs. Now, it is only going to send a certain range of information, or if you like, a range of speeds to the ESCs. You need to make sure that the ESCs are set within the correct range. So these should be set to 1040 and 1960. The maximum that you can actually set is 2100 or 2100. If you set them to 2100 and it sends a 2000 signal, obviously the ESCs are never going to run the motors at full speed, so you need to make sure that is set correctly. There are other settings that are important in BLHeli. Basically all of them are. This video is not about which settings you should run that are the best. This is specifically about those two settings that you need to make sure. However, at this point I'd recommend running the maximum amount of timing and not the maximum amount of ramp up power. Okay, the other thing to be aware on this is that there is a little trim pot, which is impossible to see. These down here by my fingernail, that is not set to 100% by default. So that means that when you get your blaster and put it together, you cannot expect maximum FPS because it's not going. So you need to adjust, well, it's not going at 100%. So you need to adjust that to increase the FPS. Now 100% is not necessarily the best thing. So I have people that like this one that wants the best FPS. Okay, so we won't buy the additional speed knob, which this has an option for, because the user believes that the maximum FPS will be achieved at the maximum possible RPM, and that will be the case on 3S, because 3S on these 2700 kV motors is not enough RPM. However, on 4S it is too much RPM, and you'll get more FPS at less than 100% on 4S. Now this has a pot that you can theoretically adjust the maximum RPM, but it's far too finicky and too sensitive, at least this one is, for me to ever set that correctly. As we reduce motor KV rating, which I think will happen in the future as drones are going to higher cell counts and lower KV ratings for various reasons, this whole, what I'm about to say, will of course change. But currently, generally speaking, on 4S, your best FPS is achieved at about 80% on 4S, which you can't really do without this. So if you want maximum performance, in this particular example, that would be achieved with 4S with the speed knob turned down a bit. And as of course, as the battery gets flatter, you could turn it up slightly. But it is a misconception that maximum FPS is achieved always at the maximum possible RPM. Otherwise, we could run like 1 trillion cell count, and the wheels would spin at light speed, and the second you put the dart in, it would be completely vaporized. So there is definitely a maximum, people call, I think, overspeed. It is a real thing, that if you send too much RPM, you actually get less FPS than had you set it to a lower amount. Oh yes, another thing to look out for is that depending on your ESCs, the idea is that these just clip onto the existing posts on the board. But this particular ESC, and they may be all different, this is like super loose, right? So that is never going to be a good thing for consistency in FPS / spin up times. If you're having problems with jamming, I'd definitely look into that. So it may be different depending on the ESC. Like these wires, actually, these are ones I added, fit on just perfectly fine and grip on well. If they don't, I just used a Y, soldered it onto one of them, and then put these into these connectors, and that sits very snugly. So that's something else to just keep an eye out for. So that's pretty much it. So this is hopefully a guide of things that you can make sure are, perfect if you want the maximum performance from your blaster. Hopefully it's been useful. Alright guys, I'll see you on the next one. Bye bye.